Hello. This next video I'm going to show you how to build the crankcase in SolidWorks for the Wighton engine. This component is 1018 steel, so again I've chosen plain carbon steel because it's a low carbon steel. Units are ANSI, inches, pounds, and seconds. Okay, so looking at the blueprint for the crankcase, it's a 3/4 inch square and it's 3/4 inches tall. So it's a 3/4 inch cube. But I am going to sketch the square on the top plane to start out using a center point rectangle. I will make these sides equal to make it a square. And I will add, for this dimension, I will add the plus or minus 1 thou symmetrical tolerance. Now I'm going to extrude it. We can do blind, or we can keep it centered, which I think is going to work out a lot better. So instead of blind, I'll switch it over to mid-plane. And if for whatever reason it doesn't work out, we can change it later, but I think it's going to work out in our favor if we use mid-plane. Okay, the height also has a 0.75 tolerance, so you can go ahead and add that whenever you want. I'm going to skip that for now. So file, save. So our crankcase, again, started with a square, extruded mid-plane, upwards the same amount. Now I can work my way in to the part or out. I don't think it makes a difference. I'm going to go ahead and start on the front to give the crankcase some definition. So I'm going to sketch on this surface. I'm going to draw a circle, and I'm going to snap it right to the center of my origin. So using mid-plane previously, it's already working out into our favor. This is 600 thousandths, and it cuts into the part 613 deep. So it's a very large bore. File, save. Next, I'm going to sketch a 600 thousandths diameter bore at the top and cut in 35 thousandths. Again, snapping to the center of the part. .600 thousandths, and we're going to cut into the part 35 thousandths. It's a very shallow bore. File, save. Next, I'm going to create the 438 thousandths hole that cuts from this surface into the next surface. I will sketch the bottom of this counterbore, draw my circle, .438, and now I'm going to cut this circle up to the next surface that it sees. So when I go to extruded cut, I'm going to choose up to surface and choose the surface I want it to cut up to. So now that hole is cutting from there up to there. File, save. Next, I'm going to add the 4 tapped holes at the top of the cylinder. They are 256 tapped holes, and they are at varying locations. So I'm going to place all 4 points individually. So with the surface pre-selected, I'm going to click Hole Wizard, switch over to a tapped hole. I want 256 from the list, and I want to switch this to say blind. So we have a 256 tapped hole. 3/16 deep. So the tap depth is going to be 3/16. Actually, according to the note, it says number 51, which would be the tap drill size. So we can actually just punch in that value right here, 0.188. And the tap will be slightly less than that. So again, a little bizarre how it's dimensioned, but that's what the note is saying. Okay, positions. We'll go ahead and place the 4 points and get them dimensioned. Alright, I could have added a few relations there, but I added the dimensions just to show you where these whole locations actually are. Go back to my isometric view, and when we hit the green check mark, our depths are good. So it looks like the tapped holes are cutting into the part slightly, which could be an issue. It may not. It looks in the view, in the front view on the blueprint, it looks like it is cutting in a little bit there, which I'm sure it's going to be fine. Okay. Next is the tapped holes that are in the front. And it looks like they are the same exact threads. So 256 threaded holes in the front. So tapped hole, 256. We'll leave the depth the same. Everything stays the same except our positions are going to change, and our surface obviously changed. So let's go ahead and put one here and here. We'll put one in the corner and one over here. So a little tedious to go ahead and dimension these points. But not difficult. Okay, so all 4 points are dimensioned. They all have a home. File, save. Next is a 157th thou hole that goes straight through the bottom of the cylinder. I'm going to sketch on the front plane just in case. Position the hole, make sure that it's horizontal with the origin by clicking the center point of the circle in the origin, making sure it's horizontal, and the distance is 0.188 away, 3/16, and the hole size is 157. So because I'm in the front plane, and I know the front plane can't be deleted, that's why I drew it there. I wasn't sure if I should have drawn it there or on the back. So when you're not sure, it's best to keep it on one of your default planes. So there it is in the middle of the part, and I'm going to extrude cut it through all in that direction so that it cuts a hole through the back of the part. So when I look at it from the front, that's what I see. Looks like there's an 1/8 inch hole that also goes through. So I could have done those both together, which I think I'm going to. I'm going to edit sketch 9. In my case, it's sketch 9, and I'm going to go ahead and add that other hole. And it's 125. There we go. File, save. Okay, the next feature is this slot cutout here, and it said same dimensions as the cylinder on the print. So we're going to go ahead and use the same dimensions on the cylinder. But my sketching surface is here. And I'm going to go ahead and put a straight slot somewhere over here. I want to make sure that the origin and the center of this slot are horizontal. The width of the slot is 3/16. The distance between them, the center points, is 0.013. And it is the same distance away from the bottom, which is 0.188. So same dimensions as the cylinder. I sketched from the top, and I'm going to cut down into this diameter. There it is. File, save. And it looks like it's finished, ready to move on to the next part.